All right, in this video, we're going to work with something called a geometric mean. So the geometric mean is, we're going to put in a definition, it's the number x such that a over x equals x over b, where a, b, and x are positive numbers. So where this will head is if you have a proportion set up where one of the cross products is the same value, in this case we have an x down here and an x up here, that's called a geometric mean, or that's the setup for a geometric mean. What we end up doing is we could solve for x by cross multiplying. We can multiply one cross product, x times x is x squared. Multiply the other cross product, a times b is ab. And then to get just the x, which is the geometric mean, it's just the x value, we would square root both sides. That's how we undo the squared. So x is equal to the square root of the cross product ab. So that's a bunch of nonsense right now, but you'll see us doing that math in a few more examples, and that x is called a geometric mean. What we recognize again is in a proportion where you have the same value as one of your cross products. It could have been over here also. You could have had x over a equals b over x. As long as one of those diagonals is the same value, you're working with a geometric mean. All right, so example 3, given triangle ABC, what is CD? So we're trying to figure out what this is right here. So I'm going to go ahead and label CD with an X. That's what we're trying to figure out. And then let's redraw our triangles like we've been doing. We can see that CD is part of the two smaller triangles. This is an altitude. It's coming from, we've got our big right triangle. The altitude hitting the hypotenuse of the right triangle creates two more right triangles, and all of these are similar. So let's look at triangle, well, here, we will. Here's how we're redrawing our triangles. And then we're just going to put some labels. We've got the long leg on the left, the short leg on the bottom, right triangle. So this will be this one right here. So as we label our side or our vertices, we can see that the right angle is D. The short leg for this triangle is D to C. So I know that this is going to be a C right here. And the long leg is D to A. All right, now let's draw the other triangle. Again, I'm not drawing them to scale. This one's going to go over here. The right angle is at, this is the triangle we're working with here. The right angle is at D. The short leg is at D to C or D to B, and it's going to be D to B is the short leg. So this is going to be a B on the bottom. And the long leg is D to C. So there's our C. Now let's label the side links that we know. We know that AD is 6.4. So here's AD, 6.4. We know that DC is X. All right, in the other triangle, we have D to B is 3.6. So D to B is 3.6. And then D to C is X. So D to C is X. Now we redrew these so that everything is proportional. So we can set up a proportion. We're going to say 6.4 over its corresponding side, X, is equal to, now I have to start with the triangle on the left, X over its corresponding side, 3.6. So if you notice, we are looking at the cross product is going to be the same value. So that's what we were looking at up there in that definition. This will end up being a geometric mean. But let's go ahead and solve. We're going to cross multiply. X times x is x squared. 6.4 times 3.6 is 23.04. Then we just square root both sides, and x is equal to 4.8. So they asked, what is CD? Well, that we labeled it with an x, so we can say CD is equal to 4.8. And then let's just take note that we notice that that CD is also the altitude of the big triangle ABC. And then CD is the geometric mean of AD and BD. So when we found X, which was CD, that CD is the geometric mean of these two lengths right there. All right, so then we have a theorem right here. The length of the altitude to the hypotenuse of a right triangle, so that's this guy right here, is the geometric mean of the lengths of the segments of the hypotenuse. So we just saw that drawn up above, so here it is in our theorem form. I don't think we need to go through that in detail because we just did the example.